Hey, Kevin, Ram.
Good morning.
Morning. Hey, Sneha.
Hello.
Hi, it's nice to meet you.
Hi, same here.
Yeah. Hey, Aaron.
Hi, everybody. We'll just wait maybe another minute or two for folks to join, and then we'll get started.
Okay. By the way, Aaron, Kevin, did you get my email?
The one from last night, you mean? Or
Yes.
yes, I think I did. Yeah.
Okay, yeah. I guess I haven't talked to Java. It seems like they when we talked about last time to do that contributions from OCP, so they did that on the Friday meeting. So I think it seems like many people attended. So it seems like they feel like I think there's a recording there. I think I probably we can use a recording unless you guys feel otherwise. We can ask them again on that.
Sure. I don't know, Kevin, if were you there at that meeting on the Friday, or? Oh, Kevin, you there?
I hear him. Kevin was there.
Hi. Yes, sorry.
No problem. Were you? Did you already catch the presentation on the OCP contribution process, or?
Me? Yes, I was there.
Okay, good. I'll check with Kosh as well. Asking you guys only since I suspect you'll be doing most of the the heavier lifting on this next round. So yeah.
So what I thought was different than what I heard in the meeting. So I thought there was a difference in the process for white papers and the specs. And I guess maybe at a definition level, OCP would say there is, but it was described to me that the Bo spec was all done as basically under a contribution license of like a white paper. So the template we use is the same one we're going to use in the PHY metrics white paper that we're working on. Does that resonate with you, Elad?
Unfortunately, I wasn't there at the Friday meeting, and I was only looking at the slides. So I guess I can't confirm or deny. I guess James maybe can comment with more knowledge.
Yeah, slides don't capture it because the slides talks about specs, and it talks about how revisions to a base spec can be simpler and all this stuff.
Right.
Okay, that's what we're talking about here. And then somebody, I think it was Cliff, said, no, the Bo spec's not done that way. It's going to be under the contribution. Anyways, that was what I heard. Is that what you heard, James?
Are you talking about like the different documents that we're using here? I mean, like the spec versus the white paper documents?
Let me rephrase what I believe Kevin's asking, or at least, and if I get it wrong, then then I'd ask that question separately. I think the question is, we plan to make a set of updates on the BOW spec, for various particular targeted things. And so the question is, does that fall into, how do we do that? In other words, is that, is the BOW spec treated more as a white paper, and we use the quote unquote white paper process to update, these particular things that we want to update, or is there a different approach?
No, I believe that the BOW is more like a spec, right? It's more a design. It's not like white paper. I think white paper is more a simple documentation, so from like informations. I think this one has a lot of design specifications, right? So design like diagram, design like a lot of specification. I think like the numbers there. I mean, like kind of like like those kind of like the latency.
Yeah, but I definitely agree. The intent is for it to be a spec. I guess the question is mostly logistical / tactical on, does that then mean that we need to move the BOW sort of document into the new specification, sort of formats, or?
I think we already published that. Probably I don't think that probably like need to change or wise to change that way because already probably out there. I think confusing people when you change that. But I guess like for the new one, maybe can start looking to use like the spec. I think there are only some structures that is different, but I think in principle they're probably not very different that way. I think only like process probably is slightly different. Document will be a lot simple. They right. I think like the doesn't require like kind of like server group review, those kind of things. Just kind of go straight directly. I think like one review, I think should be approved. But for the space, probably go to server group like reviewer, and because they're more technical content, make sure everything is correct.
So this was, I mean, this was the whole purpose of the review on Friday. So I guess I would say that's not what I heard. And I was surprised by the answer. So what do I need to do? I don't want to go through the,
So Kevin, maybe does it make sense that maybe we should have a separate meeting? Probably James, yourself, Kosh, and me. Maybe is it Cliff who's driving this? James, do you know?
I think Rom. I think I Cliff or Rom. Yeah, I think I can look out on that. Sure, I can. Let me see a meeting. I think that makes sense. Let's have a meeting to clarify that since there's
Okay. Yeah. No. Or I mean, I don't know if maybe we don't even need a meeting. It's just an email. But yeah, maybe it just sounds like we probably need just a little bit of clarity to make sure we're all on the same page, and then obviously we can proceed accordingly. But yeah, I mean, I think the confusion is the right word. The quote unquote confusion may just be that, yes, it is actually a spec, but obviously it all happened prior to these updates, which, these updates that I saw described in the slides seem like they make a lot of sense. But, now we're sort of in this intermediate thing where, we have an existing document and we would like to be able to update it, sort of to do these new features. And if we need to sort of, do an entire sort of, whatever document change for putting new features in, it's not that we can't do that. Obviously, it's just work that we'd have to plan for. So anyway, so hopefully if we can stick with largely the same format, but slowly emerge it into the new approach, that sounds like it'd be the best bet overall. But let's see what Cliff says.
yes.
yeah, I think it was Rob that did most of the talking. But Rob or Cliff could, attend this meeting. In fact, I thought that was the plan today, but these are just Jod's notes from it, which everybody here
Yep.
received. And Rob and mostly Rob did all the talking, went over the whole contribution process, which is quite
Got it.
detailed.
Makes sense. And by the way, Rob might be the right person. I was referring to Cliff
Right,
only by
But
default.
if you
Yeah.
look at the notes, although there's several methods, the work streams use the Creative Commons license, which is basically you publish a spec using and the spec or white paper go through the same within the OCP language, the same process. So anyways, that was the outcome that I heard, and certainly want to understand that but first which template to use, but importantly which process. And so do licenses have to be signed up front? Because I asked that question and the answer was no, it's the Creative Commons process. I said, okay, but that is what we need to clarify. So that's fine.
Sounds good. Makes sense.
I can, if we could do it next week, it'd be great. I'll be in a time zone where early mornings work for me. Yeah.
Let me reach out to Rob then, I think, and then see if we can available next week then. But in that case, I assume, I think when talk to Java, it seems like Kevin and some other attenders seems to be clear, and they I thought should be fine. So and has a larger audience here. So but I think since there's a question, I think it's good to ask them and see if they were able to come in and join next meeting and clarify some of these questions.
Agreed. That would be awesome.
I will see. Yeah, I will let you guys know another notes then and see if that okay with the Robin, is that he can proceed that way then, or otherwise we will set up separately.
Sounds good. All right. I think in terms of other agenda, I don't see Kosh today, so I can't bug him. But I think Kevin, any updates or specific aspects of things you'd like to go over?
So I would like to go over a couple of things, and it's pretty nitty gritty, but if you don't mind
Great.
diving details you're at a computer instead of a car?
Yes, I was. If you had said no, I don't have any updates, I was going to start asking you nitty gritty questions. So this is good.
So, so I am going to share an Excel file, which is not ideal, but so, this is how bow slices are drawn in the spec today. First, am I sharing properly?
Yeah, no, you are. Yes.
Okay,
Yeah.
so I don't have, this is part of the template questions. I don't have access to any of the figures or anything prior. So I'm redrawing things in Excel because that's how I work easily. So in Excel, this is what a slice looks like. It's supposed to look like that. I've turned it upside down because I always draw chip edge on the bottom in my marketing material, but
Yeah, and just to jump to something that I suspect you're about to say, as far as I know, most people actually probably do a double row of power, just to avoid this annoying stagger and also because you need power for all kinds of good reasons. But yeah.
that was one of my questions. Usually we have a double, or we have extra power and draw it differently. But no, what I was going to talk about, so this is how I would stack 4 slices with the stagger, which is now from now on call it the annoying stagger. That's good
Yep.
and I don't usually drop that way. But what I wanted to do was, using this as a base element, which I think we're saying people agree this slice can be represented by something that looks like this, at least for this working group until we have I have better drawing tools. What I wanted to do is explain an example of bidirectional, and there's basically 2 ways to do it because I want to have 2 clocks. So one way to do it is to take a group of 32 like this. But another way to do it is to put 2 slices side by side. And that's the easiest to explain. So I'm switching to another tab. Is this coming through?
Mm-hmm.
So the idea is I've got a clock that's set up as a TX clock and a clock that's set up as an ARC clock. I'm not dynamically changing those. These signals in the middle then can use either timing reference, and they could be bidirectional data that switch back and forth subject to, discussion on the switching mechanism. That's the basic idea. Again, they could be stacked on top of each other or side by side. But for most memory, you need some unidirectional control information in addition to bidirectional data. And this
Yep.
is I was proposing to use 2 existing bow slices, not modifying them, at least at first. And then I have a group of unidirectional control and unidirectional RX, or control going the other direction. But in most memories, control bandwidth is not symmetric. So
Right.
what I want to do is something like this. And I drew this figure as a way of trying to explain what I've been verbalizing before, but I don't have the right context. So the idea is you say, well, but this PHY and this PHY don't look the same. Well, that's true. Memory PHYs are always the mirror of the associated ASIC PHY. They're going to have, in this case, a few unidirectional transmitters, and then the SoC would have a few unidirectional receivers because there's not much back pressure data going, but there's a bunch of address and command data going from SoC to memory, and the data in the middle is bidirectional. So this is just a super coarse high level, but I wanted to explain the thought process of where I was going before I'm writing specs or anything like that.
Right. No, I think the thought process makes sense. Maybe one question or clarification. So the intent is, and I'm just going to use the terminology. So the idea here is that this now becomes a quote unquote slice. And obviously the slice is a more composite structure than what we referred to as slice previously, but this is the slice.
Right. And it can be stacked, stuff like
Got
that.
it. Okay, makes sense. And so in this particular picture, it's something like either 16 or 18 bidirectional data lines.
Yeah, probably
You
be
know,
eight.
the equivalent of CA bus looks like it's 8, and you know, sort of whatever. I suppose the thing in the other direction is mostly just some sort of coordination. Like I guess the DRAM spec, you know, the DRAMs themselves usually don't have that other direction, right?
Uh,
The two on the right.
yeah, I mean, most memories, HBM does, but most memories
Got
do
it.
not.
Okay, got it.
For things like, it actually, if there's modern, actually DDR does too now. There's if there's an ECC error, something that happens in the core has nothing to do with the data going back and forth. This is how you report it back.
Gotcha. Okay, got it. Makes sense. Makes sense.
Or you can-
One question, Kevin. Kevin, one question.
Oh,
How
yeah.
much is the overhead for these control signals?
Say that again? How much is the
Uh,
overhead?
how many extra wires over a memory interface you would need for the control of these signals? Dedicated controls.
Well, so at this point, there's no extra wires other than what's needed in a memory interface, and this is just conceptual. I haven't shown, for example, Bo has a nice aux pin that can be used for communicating sideband information. We probably want to keep something like that. And as Eli pointed out, you probably want 18 bits in the middle instead of 16 because you want to carry the ECC or metadata information that goes back and forth. But I haven't added any wires other than what the memory would need so far. I'm just trying to explain the concept of bidirectional in the middle using these timing references, unidirectional data on one side using the same timing reference, unidirectional data on the other side using the same time reference. And the side going, you know, top to bottom is a different in all memories a different bandwidth than going bottom to top. Like Eli said, many cases it's 0, but I'm just showing both for.
Right. So Majid, and I think maybe I'll attempt to answer it in a slightly different way, and then I'll convert it to a question. As far as I know, you know, every sort of DRM spec ends up with slightly different, you know, sort of definitions of effect. You know, they refer to it as the CA bus, right? The, you know, command and address kind of things, and you know, I think every DRM generation ends up with slightly different things there. So I suppose, Kevin, this one's mapped specifically to HPM. Is that right?
Kinda, I mean, HBM has 64 data wires and like 18 command and address. But if you run them faster, you can funnel, you know, the 64 data wires down to 16
Okay,
or
got it. So you tried to maintain the ratios, but obviously, but not necessarily, you know, pin counts or whatever.
yeah, you might only need 3 or 4. But HBM also has overhead like parity, and they do other stuff. And a person may want to use FAC instead of parity particularly for the command and address. So I haven't gotten into the details, but yes, high level, it would correspond to a higher data rate, but the same kind of signals that already exist on the memory.
Makes sense. And so one other question, I suppose, right, I mean, again, I'm not as familiar with HBM, but, you know, there's all these sort of like high voltage lines, you know, clock enable reset, things like that, at least in some of the traditional, you know, the other DDRs. I assume that these would also be carried sort of over the data die, and then sort of, you know, yeah, is that the thinking, or not sure yet?
So the ideal thing would be to carry all the signals over the data die. There are, yeah, you're right. There are some signals that might be better carried over a GPIO like interface, IEEE 1500 test.
Right. No, by the way, I'm not actually opposed to carrying them over the data die at all. It's just that if we do, there's kind of additional, let's say, boot considerations and, you know, sidebands and whatnot that we have to just define. And that might be the right answer, by the way. It's not, you know, not pointing in an opposite direction per se.
Right. Yeah, I think including an aux sideband like situation for boot and control is a good idea.
Okay, makes sense. And I guess maybe to clarify, my thinking was that we might actually want to sort of, you know, spec out how you how you plop on explicit BOW sidebands, you know, either on a, you know, I don't know if it's a per slice or per, you know, sort of larger unit element, but yeah, that we probably want an explicit sideband, just to the, yeah, basically because the idea is that the sideband actually works immediately out of reset, whereas main band slices may not. So yeah, so that would just help out, especially if we are carrying, you know, resets and CKE and stuff like that.
Yeah. So anyways, this is what I wanted to do was, I mean, eventually I want to draw it so it looks pretty, and I want to get some, but I really right now just want to get feedback. I think these are good ones about needing to include the aux and needing to include the number of bits going each direction reflects whichever memory interface it's being designed for. So it's I envision that the boat 2.1 it's not so much that it's defining an exact slice, but that it's defining you know, the direction of how a memory interface could be redefined using Bo. And if it's a DDR interface, it might have a different number of bits than an LPDDR interface, for example.
Right.
Very likely. And so the PHY themselves will have the ability to, you know, smoosh in and out in size depending upon the actual application. It's less trying to define, you know, a rigid, this is the memory interface, but this is the how a memory interface would be built.
Gotcha, makes sense. So actually, along those lines, another nitty-gritty question, maybe two. So is the thinking that, you know, kind of TX clock and RX clock are continuously running, or are they sort of more analogs of you know, WDQS, RDQS?
So that's would be a great thing to get people's opinion on. My personal opinion is continually running. The way a lot of them run is they have a continuously running clock, and the command and address is set with respect to that. So you can send it anytime, and you don't waste latency waiting up.
Right.
The reason strobes work in memories is because you've already gotten the command that tells you, you know, write data is coming or read data is coming sometime later, and you have time to turn on the strobes and let them propagate through all the clock insertion delay and get everything all shook out and ready to go before memory traffic is going to be transmitted. But you don't really have that luxury on command and address. So I, you know, at least think the TX clock has to be on all the time. And the clocks don't take that much power, I don't think. So it's easiest from a design standpoint to leave them on. I was looking through the Bo spec. The Bo spec supports both. It has the idea of preamble and clock stop and that kind of stuff. So in theory, I could try to leverage that to have it more like a strobe mode. I guess I could write it. We could write it so that it could be done either way, but point out the drawbacks on latency if you know, can't send.
Right. I mean, I guess there's some other logistical considerations, like for example, as you're saying, the DRAM is expecting a continuous CK and the strobes to be, you know, sort of strobes. You know, so if we make this one discontinuous, it just implies something about the memory side interface and, you know, sort of it, quote unquote, regenerating a clock or whatever.
Yeah, true. And, you know, typically in a memory, this T clock, X clock is provided by a PLL and it gets looped back as the RX clock.
Right.
That RX clock has higher jitter and isn't as clean. DRAMs hate to put PLLs on DRAMs. This has been true forever. But if you have a die-to-die interface and you're building a memory chiplet that uses some kind of FinFET process, I mean, I'm of the mind that there's no reason not to have a PLL on both sides. That's how standardized work, as long as they use the same reference clock. But you know, it could be written to work either way.
No, makes sense. Makes sense.
In fact, I'm going to make a note of that. I meant to capture this in PowerPoint to present here cleanly, but it's just, I got too much on my plate right now, and I just wanted to talk through it more than, present like some final.
No, makes sense. And only for sake of discussion or whatever, if we were to sort of do the unidirectional version of this, it would sort of, in principle at least, quote unquote, just expand the middle part, so that you'd have double of the data lines, possibly, but everything else conceptually would sort of look the same.
Yeah, yeah, for the case, you mean the case you're talking about, which is the memory chiplet connection. I like what you said earlier, which is that possibly well, let's just say there's two sub-applications under your column of memory chiplet traffic. You want to support full write bandwidth and full read bandwidth, then obviously you need extra unidirectional control signals on top, and you have to build a PHY that is, again, asymmetric, kind of like this. But if you're willing to, like many people are, say, look, I don't think my write bandwidth is gonna be the same as my read bandwidth, you might be able to have a fully symmetric PHY, in other words, a bow PHY exactly as it exists, and have the write traffic be, all the command address and 50% of the write bandwidth multiplexed, and the read bandwidth is fully supported, in which case, and I think you've indicated you've already built memory chiplets. We've also done that. So that's what people do when they don't want to have asymmetric PHYs. And asymmetric PHYs are already, I think this is already allowed under the Bose spec from what you described.
It is, yep.
It doesn't have to be ingress and egress identical. It's weird to do it, but memory is really an application where it kind of makes sense. A lot of control information goes one way, it's not coming back.
Yep.
Unless you're willing to cut down on the write bandwidth, you're gonna have to be asymmetric. So that's the thought process.
Yep, makes sense.
Okay. That's all I had for today. I did, I guess I wanted to remind people, one of the things Boppy did before he left was set up a 2.1 space. And he created like a memory, he created some documents, but they're literally just blank data sheets. So they're not in a template or anything. I want to create one that's in a template. But we're trying to, in this presentations folders, why don't names show up? Well, anyways, these are some presentations that I uploaded previously, and anything I present in this group, I'm trying to upload in this space so we can keep track of it. That's really weird. Why does... No, what am I doing wrong?
What are you trying to do?
Folder names disappeared and the file names disappeared. Why not? I'm just how I'm displaying it, I guess.
Oh, that's weird. Yeah.
No, it's me. Wrap modify name. Oh, can you refresh the page?
Refresh the page. Oh, okay. Oh, yeah, there it goes. Okay, so presentations that were made in this, and refresh this page.
Looks like it, yep.
For some reason the file names aren't showing here, but there are different dates of files. I don't know why it looks like this. And I usually number
again.
I number my
There we
file
go.
with the date it was presented, just so they'll be uploaded in order. I'll upload today's material as well.
Great.
And that's at least a starting direction to work with. Okay.
Great. Thanks, Kevin.
Good.
And
Good progress. I thought Chiplet Summit had some good feedback, and there seems to be good energy. So hopefully we keep moving this forward.
yeah, for sure. All right. If anyone else has any topics they'd like to go over, please feel free.
Just quickly kind of go over though. I think like have we decided, or when we're going to decide like what we're going to be included in 2.1? Any like that, or anyone has any thought about
Yeah,
that?
no, there's sort of even a roadmap document, so to speak.
Oh, okay. Where is that? Is that on that folder or?
I need Kevin is I don't remember, is that in there, or I think Poppy had that separately, possibly?
So we copied, so I don't know about a roadmap document, but we did the presentation during the Chiplet Summit tutorial, right? And that
Yep.
was what's coming up in Bo 2.1, which had some material from Shahab, some material from Kosh and Ahmed on your chip, and some slides from me. It's pretty high level, but I'll drop that in here as well. So that serves kind of as a guideline of where we're going. I'll drop it in at the top level of 2.1.
Yeah, I need to go dig it up, but I believe Poppy had put together sort of a document of, you know, a Google Doc thing of, okay, yeah, you know, here's the different pieces we want to put together, and you know when and all that. I'll go see if I can dig that up in the background.
Cool.
But based on like Kevin, I think based on that Chiplet Summit feedback, I think I like with those presentations, do you think like if anything that we need to change or like add or anything like that on based on that roadmap that you guys have thinking, like those kind of directions? Like memory, I think like IoT on AI, like
Yeah, I think the three optical, memory, and IoT that he has in the Bo 2.1 directory matched exactly with what we presented. So nothing changes there.
Yep.
One of the things James asked me separately offline was this is all focused on the Bo 2.1 spec. What about the link layer spec? And I told him there were some discussions around the potential need to modify that as well, but I'm frankly not that familiar with the Bo link layer spec, and I don't have any insight to what would need to be modified there. So I couldn't give any guidance.
Got it. Yeah, no, I mean, I can comment a little bit on that. So yeah, I mean, and again, this is modular, some of the applications or whatnot, but you know, certainly defining or you know, sort of publishing, you know, what might be the memory interface, you know, sort of the selected version of AXI or versions that you know would be associated with that would make a lot of sense. There's other pieces that, you know, specifically whether it's link layer or not, maybe is kind of another question, but you know, in the version of things where you are kind of, you know, somewhat literally carrying the DRAM pins, yeah, we should sort of make a decision as to whether or not, you know, that mapping is something that should be captured by link layer or would be captured by PHY. You know, we can take the approach of sort of, you know, describing the strategy in sort of the PHY document and then having similar to what the link layer does, you know, people publish, okay, well, you know, here's the specific way I did it for this particular, you know, sort of DRAM technology. But yeah, there are some decisions, let's say across the groups that we should make, you know, as we get farther along on this.
I see. So it sounds like they need to be determined down the line, but probably not today then. So I have to kind of discuss too, starting from the PHY side.
Yeah, that's right. I'd say, you know, for right now, I think there's enough clear independent work that you know we can continue. But yes, there will be some questions we'll come to that, you know, we'll need to make some joint decisions on.
Right. So and this is same for both on the photonic and also on the memory side.
Correct. I mean, I think, well, maybe that's not true. I was gonna say, I think memory is the most obvious one that'll have cross-group interactions, but that might not be true. You know, IoT arguably would have that as well. So anyways, you know, as we get farther, we'll have more concrete, I think, you know, decisions and questions to make, you know, to make calls on.
Right. I think there's this really I think group that's starting and then kind of like working the next spec, right? So I think I just want to see if that makes sense to cover these things and all. But sounds like it's probably good to wait until I think like for some time and has more clarity on the PHY side first and before decide.
Yeah, I mean, I think, you know, certainly we should make sure everyone is aware of the activities, you know, because that may, you know, they may want to get more insight on, you know, what's happening, you know, sort of currently, even purely in the PHY group. But yeah, I think that in terms of decision making, you know, it'll be probably better once some of the things are more concrete.
Okay, that makes sense.
Okay, so I dropped the OCP tutorial slides into that same folder that hopefully everybody can access. I got to drop to run to a meeting, but it's a good discussion. Thanks for the feedback today, everybody.
Great. Thanks so much, everyone. Talk to y'all next week.
Yeah, thanks everyone.
Bye-bye.
Thanks. Bye. Bye.
Bye.